AO 2.4 graphing equations in standard form. Here we go. Let's jump right into it because I think this one could be quite simple and we can get through it pretty easily. Alright, the blank of a linear equation is ax plus by equals c, and a and b are both not 0. This is standard form. Alright, this right here, ax plus by equals c, standard form. And how do we actually go about graphing an equation that's written in this form? And truthfully, I'm going to show you two different ways. And the first is what I personally think is important and what you should do. And it's converting this standard form equation into a slope-intercept form equation. Which essentially is like going back into the last chapter to solve equations for variables. Because if you remember, slope-intercept form says y equals mx plus b. Right, so that means I essentially want to take this equation and solve it for y. I want y completely by itself. So if we think about doing it that way, the first thing I want to do is take all terms that don't have y's and move them to the other side of the equation. So I'm going to add 2x and add 2x to keep it balanced, right? And then after this, that's gone over there. It says 3y equals, and I got a 2x and a negative 6 on the right side. And now what I need to do is I need to divide by 3 to get y completely alone, and then I make sure I divide everything on the right side by 3 to get it completely alone. So y equals 2/3 x minus 6 divided by 3 is 2, minus 2. So now I have the exact same equation written instead in slope-intercept form. And it's a lot easier to graph. Correct? Now I'm going to go about getting my lines set up. Do one right there. Do one right there. And then I'll plot some points. I know... Oh geez, I shouldn't have done that. My y-intercept is actually at -2, so I want this to be higher. Let's put it right there. Y-intercept of -2 means I'm going to be right here. Now I need my slope. My slope is going to be 2/3. So I'm going to be going a rise of 2 and a run of 1, 2, 3. A rise of 2 and a run of 1, 2, 3. Then I could go and I could draw my line through it. There we are. That's my equation, graphed in standard form. And now, I do have a different option. I don't have to convert it into slope-intercept form in order to graph it. I can graph it using intercepts. Now, we talked about intercepts, was it last video or the video before? But we talked about them and how they're very specific towards what the x value and what the y value are going to be. So in the x-intercept, I know for a fact that the y value is going to be 0. So this is going to take place at a point where y equals 0, and that the y-intercept is going to take place at a point where x equals 0. Right? So if I'm thinking about how I'm going to graph using intercepts, I can essentially get two different points. I can get the x-intercept and the y-intercept very easily using this standard form. And I'm going to show you how. If I know that the x-intercept exists when y equals 0, what if I took the equation and I said, okay, y equals 0? If y equals 0, what does x equal? Well, that's going to be 3 times 0, that's 0. X equals -3 when y equals 0. So I have a coordinate point there. I have a coordinate point, -3, 0. And that's my x-intercept. I could also alternatively do the exact same thing to find the y-intercept. I could say, okay, the y-intercept means that x equals 0. So if x equals 0, then why don't I put that in? 0 plus 3y equals -3. Alright, so that just means I got to divide by 3. Y equals 3 divided by 3 is 1, but that's a negative divided by a positive, so that's -1. So I have another coordinate point there, 0, comma, negative 1. Now I have both x-intercept and y-intercept, 2 points on a graph, which is enough to graph it. It's absolutely brilliant. So why don't I go ahead and make this here. I'll just put these right down in here. Do it 1 there, 1 there. Brilliant. Alright, negative 3. 1, 2, 3, comma 0, and 0, negative 1. Beautiful, look at that. I just plot the intercepts, connect them using a line, and we're done. It's that easy. Alright, so 2 different ways. You could convert it into slope-intercept form, or you could use intercepts. Either way, it's fine. And for the example, I'm going to go ahead and stop that. Getting a little bit tired of it. Example 3. Real life application. Here we go. You have $6 to spend on apples and bananas. Now, you do not like to eat anything that is not an apple or a banana. So that $6 has to really stretch, because you're covering like everything you're ever going to eat this entire week. Just apples and bananas, $6. Graph the equation 1.5x plus 0.6y equals 6, which seems to be just a random collection of numbers and variables. But there's a comma and it's going to tell me what everything means, where x is the number of pounds of apples and y is the number of pounds of bananas. And then we're going to have to interpret the graph after that. Alrighty, so let's go ahead and graph it. I am going to go ahead and graph by intercepts, because I think that's the easiest way to do that right here. So let's go for it. I have 2 different pieces of information. I'm going to put in where y equals 0. I'm going to put in where x equals 0, because that will give me the x-intercept and the y-intercept. And let's go. So I have 1.5. We're putting in y equals 0 first. 1.5x plus 0.6 times 0 equals 6. So once 0.6 multiplies by 0, my equation essentially says 1.5x equals 6. Alrighty. How many times does 1.5 go into 6? I bet you all can figure that out now. It is a 4. Congratulations. We now have the coordinate point 4, 0. Now, let's look at getting the other intercept. 1.5 is now times 0 plus 0.6 times y equals 6. Alrighty. Now, once the 1.5 multiplies 0, my equation basically just says 0.6y equals 6. How many times does 0.6 go into 6? This should be very, very easy. Please tell me you got it. It is 10. So I also have another coordinate point that says 0, 10. Woohoo! 2 coordinate points, 2 places that I can graph, and I can create my visual representation of this equation. So I'm going to go ahead and start making some lines. Let's make one going down there. Let's make one going across there. My x and my y axis. I'm going to plot some points. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo! I left enough space. And 4, 0. 1, 2, 3, 4. I plotted the first one wrong. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh crap. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, just barely. So this first one that I made was wrong. Now that I have my 2 points, I can connect my 2 points. I'm gonna have to fix that a little bit, but that's okay. Beautiful. Now, I have it graphed. Interpret the intercepts. This is always the struggling point. Interpret the intercepts. What does it mean right here when my x value is 0 and my y value is 10? In terms of the situation, what does it mean? Well, x stood for pounds of apples. So it means that I had 0 pounds of apples. I made the choice to not buy any apples and buy 10 bananas. Or 10 pounds of bananas. So the y-intercept tells me I choose no apples and 10 pounds of bananas. My x-intercept, on the other hand, the exact opposite end of the spectrum, tells me I chose, because the y is 0, I chose 0 pounds of bananas but instead 4 pounds of apples. Alrighty. Very good. That's the end of it. Congratulations, you have made it through. I will see you guys next time. Make sure you work on the assigned problems. Remember to ask me questions and that you write them down. And I will see you later.